Hello everybody. Today we're going to review what to do with exponents, and we are only going to review exponents that are constants. So exponents that have a value that's a number. We are not going to review what to do when exponents are represented as variables. If we have exponents as variables, we are usually rewriting those as logarithmic expressions and equations and then solving those. But for now, we're going to stick with exponents that are just numbers. So we want to make sure we review our rules of exponents. First one is, what do we do if we have a fraction and we have the base in both the numerator and denominator, but different exponents? So something like this first example here, x to the a over x to the b. Our rule is we take the exponent from the numerator and we subtract the exponent from the denominator. So first comes the numerator exponent and we subtract the numerator from the denominator. Excuse me, we subtract the denominator from the numerator. So that if we have something like y to the fifth in this first example over y squared, using that rule I would subtract, take my 5, subtract 2, and get y to the third. And you can see that that would work if I wrote out all of the values of y in the numerator. Y to the fifth would be y times itself 5 times. And if I'm dividing by y squared, written out, it's multiplied twice, and I can just cancel those common factors, leaving me with y to the third over 1, or y to the third. And then similarly, if I have a fraction with the same base, different exponents, but there are fewer of my y terms in the numerator than the denominator, like in this example, y squared over y to the fifth, when I use my subtraction rule and take my 2, subtract the 5, I get a negative number, y to the negative third, which gives me the same thing if I were to write it out with my y's being multiplied. Don't forget, when we cancel out factors that are equivalent, we really are left with 1s. So this would really end up being 1 times 1 over 1 times 1 times y to the third, which gives us our 1 to the y, or excuse me, 1 over y third. Same thing then as what we got over here. This is equivalent to y to the minus 3 power, which really gives us our exponent rule. If I have a base raised to a negative exponent, I can write that as a fraction 1 over x to the same exponent, only positive. Most of us are pretty familiar with that rule. We're going to use it. Here's a quick example. If I have x to the minus 4, I can rewrite that as 1 over x to the positive 4. So my negative exponent here becomes a positive if I put it in a denominator with a 1. Let's take a look at this next example. If I have ab to the negative 6, the only base being raised to that negative power is the b, not the a. So this is the same thing as saying I have a over 1 times, I'm going to take my b to the negative 6 and write it as 1 over b to the positive 6, which gives me this a over b to the 6th. And there's another example here you can see. Just remember, only move the base that is attached to a negative exponent from a numerator to a denominator when you change the sign on the exponent. And you can do the same thing if you have a negative exponent in a denominator. You can move only the base attached to that negative exponent from the denominator to the numerator, and then change your exponents so they are positive. Alright, so let's go ahead now and look at our next example, which defines what happens if we have something to the 0 power. If I have, in this example, x to the 4th over x to the 4th, we know that if I have the same numerator, same denominator, this is really equal to 1. But if I use my rules of exponents and I take my numerator exponent and subtract the denominator exponent, I get x to the 4 minus 4, or x to the 0, which we know equals 1. As shown here, if we write all of our x's out in the numerator and denominator, and then cancel these really become all 1's. So I end up multiplying 1 times 1 times 1 times 1 over the same thing, giving me my simplified answer of 1. So that gives us our other rule, x to the 0, or really anything to the 0 power is going to equal 1, as long as we are not taking 0 to the 0 power. Don't forget, this will not work if I have, like in this example up above, okay to have zeros in the numerator, but not okay to have them in the denominator. So this would be undefined whenever I have zeros in the denominator. So that's why we have to say anything to the 0 is 1, as long as our anything is not equal to 0. Okay, well, let's start taking a look at some examples. This first one here, I'm going to simplify 4 squared, but that's being raised to the 0 power, and then we're multiplying it times 8 to the negative 1. This thing here, this entire quantity 4 squared, is being raised to the 0 power. So I can replace all of this to the 0 power with 1. And now I'm multiplying it times 8 to the negative 1 power, which is the same thing as 1 over 8 to the positive power. So simplified, this is 1 over 8. Moving on to the next example. This time we are asked to write this fraction without a denominator. That means we need to move everything in the denominator up into the numerator. So if we're going to do that, we are going to need to take everything that's in the denominator. If I want to move it to the numerator, I'm going to have to rewrite it so that it is written with a negative exponent. To move this up into the numerator, I'm going to have to write it now with an exponent of negative 1. So let's see what happens when I do that. I'm still going to keep my 4x to the third, and now I'm taking 2x to the 5th, y squared, raising all of that to the negative 1 power. Now I'm multiplying some things here with an exponent, raising them to another exponent, and some things don't show an exponent, so really I know that that is understood to be an exponent of 1. So my 2 here, I'm just going to rewrite for now as having an exponent of 1. And see what happens now when I take everything in the parentheses and raise it to the negative 1 power. I multiply my exponents, so I'm going to have this times 2. 1 times negative 1 gives me negative 1. 5 times negative 1 gives me negative 5. 2 times negative 1 gives me negative 2. Alright, so then next I am going to see if I have things with the same base. X to the third here, x to the minus 5 here. Remember now, when we are multiplying same base, I add the exponents. So I'm going to write my 4x, and then I'm going to add my 3 and my negative 5, get negative 2. And I still have this 2 to the negative 1, y to the negative 2. But I have numbers here and here, and if we think about it, we can rewrite our 4 with a base of 2. That way we'll have bases of 2 in common. So I'm going to replace my 4 with 2 squared. Still got my x to the minus 2 times 2 to the minus 1, y to the minus 2. Now, same base here with my 2's. I don't want to multiply the 2's together. I want to do the same thing that I did with the x's. Same base, I want to add my exponents. So 2, when I add my exponents together, 2 and a negative 1, I get a positive 1. still have my x to the minus 2, y to the negative 2. So, simplifying and rewriting my original expression with no denominator becomes 2x to the negative 2, y to the negative 2. Alright, moving on now. Next example. We are asked to simplify, and I have something in parentheses being raised to a power. So I'm going to take each of the terms in parentheses and raise them to that exponent. Gives me 2 to the negative third x to the negative third multiplied by 2 times x to the negative third. Now again, I'm going to look for same bases. I'm going to, even though it's not written there, I understood to have an exponent of 1 here. So I'm going to rewrite this. Adding my two exponents becomes 2. Negative 3 plus 1 gives me negative 2 power. And then I have x's also, same base, so I'm going to add my exponents. This becomes x to the negative 6th power. Okay, we could leave our answer like that. Some of you might prefer to write this with positive exponents. If we do that, we are going to have a fraction. So I will just go through and show you what else we could have. My 2 to the negative 2 would be the same as 1 over 2 squared. And then the x to the negative 6th power would be the same thing as multiplying that by 1 over x to the positive 6th, which gives me 1 over 4x to the 6th. So either one of these answers are considered correct. Let's move on now. One more example here. A little bit more complicated, but nothing we can't handle. So I'm going to take this one step at a time. Couple ways we could do this. Some of you might prefer to work with this thing without this negative exponent here. Some of you might prefer to take everything in parentheses to the negative 2nd power first. Let's go ahead and, well, we'll go ahead and do both ways. So first thing I'm going to do is take everything that I have in parentheses, raise it to the negative 2nd power. So method number 1. I'm going to rewrite this as 6 to the negative 2 power x, and then multiply my exponents. 2 times negative 2 would be negative 4 y to the negative 4 times negative 2 is going to give me a positive 8. For some reason I'm having trouble writing. Okay, and then in the denominator, 2 to the negative 2 power, x to the positive 6th power, y to the negative 4th power. Now I am going to rewrite this so that I have only positive exponents, which means anything, any base that has a negative exponent, I'm going to move. If it's in the numerator, I'm going to move it to the denominator. If it's in the denominator, I'm going to move it to the numerator. So this, starting out 6 to the negative 2 power, I'm going to write it, change it from the numerator to the denominator, make my exponent positive. And I've got this x to the 4th as a positive will be in the denominator. Y to the 8th, I'm going to keep where it is. What was in the denominator with a negative exponent, I'm going to move to the numerator. And then I'm going to keep my x to the 6th right where it is, move my y to the 4th into the numerator. So let's just combine our x's and y's where we can. And I'm going to also take my base of 2 and raise it to the 2nd power, and the same thing with the 6th, I'm going to raise that to the 2nd power. So to begin with, I'm going to write the numbers first. 2 squared would be 4. Then I have y to the 8th times y to the 4th, so same base, I'm going to add my exponents and make that y to the 12th. 6 squared, 36. Add my exponents with my base of x. and I get x to the 10th. Now my 4 over 36, they have a common factor of 4, so I'm going to divide 4 into both of these, and I end up with y to the 12th over 9x to the 10th. Okay, so that's one way we could have done that problem. Let's see what happens if I do that second method. And let's say what I really want to do first is not have to deal with a negative exponent there. I know that I can switch things from numerators to denominators. So I'm going to switch those, and then I'm going to make my exponent a positive 2 instead of a negative 2. So rewriting that, everything that's in the denominator, just the way it is, I'm going to move to the numerator, because that whole thing is part of what's getting raised to the negative 2 power. And then I'm going to move my entire numerator just the way it is, and then give it now a positive exponent. And from here, I'm going to take everything in parentheses and square it. So now this becomes 2 squared. Actually, let's be consistent. Let's say that we didn't like any of these negative exponents and we wanted to move them. So I'm actually going to take this and move it down here, and then square what's down there. So let's say I'm moving that to the denominator, and I'm going to erase what I started to write here in the numerator. Okay, so I'm going to be moving my x to the third. My y squared here is going to be taken to the second power, so that's going to become y to the fourth. Down in the denominator, now I've got my 6, and I'm going to be squaring that. Now, let's not forget, I have that x to the minus 3 that I'm going to write here as x to the positive 3, but I'm going to square that, and 3 times 2 gives me x to the 6. And then I have this other x squared here, so I need to put that in my denominator as well. X squared, but I'm going to take that to the second power, it becomes x to the fourth. This y, if I'm going to be consistent with how I'm treating my negative exponents, I'm going to want to move that to the numerator. So I'm going to write it up in the numerator, y to the fourth, but I want to square that. It's going to become y to the eighth. Hopefully I haven't lost anybody on this so far. Now I'm going to start simplifying. 2 squared gives me 4. Combine these exponents from my y's by adding them. 36 in the denominator. Combine my exponents to be x to the 10th, and as you can see, I'm getting the same thing that I got using the first method. Going to factor out a 4 out of both of these, and I end up with y to the 12th over x to the 10th. Whoops, can't forget my 9 there. So same answer that I got using the first method. Alright, let's now take a look at what happens when I get expressions where I have these exponents that are negative, or fractions, and radicals at the same time. Now, if you were able to watch the video yesterday, we reviewed what to do with radicals and how we can exchange our radicals with exponents. So this part here, we looked over yesterday. If you picked up the notes for this, there's a spelling error here on your notes, not in this thing here today. But point was, we did this in another video, so this should be a repeat for you, but that's okay. Looking at it again, just to review, if I have something that I'm taking the cube root of, I can rewrite it as x to the 1/3 power. And notice what happens up here. Also, any index that I have becomes a denominator of my exponent. Anything inside the radical or even outside becomes numerator of my exponential fraction. So quickly, just quick review looking at these examples 1 through 3. This has square index here. So I can write this as still x to the third, or 3 over 1. The denominator is my index of the radical. In this second example, index here, 3. That's going to be the denominator of my exponent. I've got a, denominator is going to be 3. A is to the 9th power, that goes in the numerator. This can be simplified. 9 over 3 becomes 3. In this third example, 5 is the index, that becomes the denominator of my exponent. 10 is the power that 2 is being raised to, that goes in the numerator. And I can simplify that 10 over 5 to be 2. Take 2 to the second power, get 4. Okay, so here we go. Let's look at some examples where we're kind of mixing up. We've got some negative exponents, some positive exponents, and we've got radicals. So we want to put everything together. Lots of ways that our answers might end up looking like. Could be in all exponents, could be some radicals. So if nothing is specified, then there's multiple ways we can represent this. But let's go ahead and start simplifying this thing. I've got 25 being raised to the negative 1/2 power. So I can write that as, I'm just going to write that as a negative 1/2 right now. X to the 6 being raised to the negative 1/2 power, so I'm going to multiply those. Get negative 3. I've got a denominator with a 10 being multiplied by x squared, but I want the 5th root of that, so I'm going to write that with a base of x and write this as an exponent. 5 is my index, that will be the denominator of my fraction here. 2 is my power I'm raising x to. So this is what we've got so far. I'm going to take this 25 to the negative 1/2 and bring it down into the denominator. So I'm taking this, moving it. That's the base of 25 with a negative exponent. So I'm going to move it and write it with a positive exponent. Still got that 10 there. And I think I'll also take this negative exponent, negative 3 with a base of x, put that in the denominator as well, make it a positive. So it looks like everything's going, I'll make sure that looks like a dot. Everything's in the denominator, but I do have a 1 still, understood to be in the numerator. So here's what I've got. 1 over, now 25 to the 1/2 power, same thing as the square root of 25, that's 5. Multiplying that by 10. And then I've got these x's, same base, so I'm going to add my exponents here. 3 and add that to 2/5. So I've got x to the 3 and 2/5. Well, if I make that into one improper fraction, I would have 17/5. Because I can put those two numbers together in the denominator, let's simplify things by doing that. So here's one representation of an answer. I could also see that written as 1 over 50. Let's see, this 17 over 5 was the same thing as x to the 3rd times x to the 2/5. Possibly see this.
Royal Allen, please meet your mother outside right away. Royal Allen, your mother is waiting for you outside.
Alright, sorry about that interruption. Could see something like this. If I have, now remember, I'm replacing my x to the 17/5, understanding that that is the same as x to the 3rd times x to the 2/5. So I wrote the x to the 3rd power by itself here. I'm going to write this as a radical. The 5, the denominator, is my index. X squared is what's under the radical. You could see a multiple choice answer like this. Now please beware. You cannot leave a radical in the denominator if you are working a problem and coming up with an answer where you are giving your work and showing your answer. Okay? So if this is a problem on an exam just the way it is, we cannot leave radical in the denominator. However, for some reason, on exams from the state, they will sometimes give you multiple choice questions, and the correct answer does have a radical in the denominator. This is why I want you to be able to recognize this kind of answer. However, if you had to show your work and leave an answer, you would be better off giving an answer like we got originally. This one, where I don't show a radical, I have x with an exponent that is rational or a fraction. Okay, let's move on. A couple more examples to get through. These get kind of messy, but good practice for you in working these things with negative exponents and radicals all mixed up. Looks like we have a numerator. Looks like actually we have a complex fraction. This is our longest divide by sign. So this is something where we have a numerator and we are dividing by a fraction. So a couple things we can do, but right off the bat, if I'm dividing by a fraction here in the denominator, it's the same thing as multiplying by the reciprocal of that. So that's the first thing I'm going to do in this example. I've got 25, and that's being multiplied by the cubed root of nm squared, all raised to the negative ninth power. Being divided by a fraction means I can write it as being multiplied by the reciprocal of that fraction. So I'm going to write this and put down a multiplication sign and then the reciprocal of my denominator. Alright, now I've also got some negative exponents that I can turn to positive exponents. This first part here, the negative ninth power. How about if we first take everything in parentheses and bring it to the negative ninth power? Then I would have 25. And that's not to the third power there. Please be aware that's the cubed root coming up after that. So I've got 25 to the negative ninth power. And then I'm going to write this radical as an exponent of 1/3. So I've got nm squared to the 1/3, all being raised to the negative ninth power. Messy problem here. Times 2 to the nm over 4 to the negative 2 power. Let's bring that up. Make it a positive 2. So now I don't even have any more denominators. Or actually my denominators are all 1. Alright, so this is what we're working with from here on out. This 25 to the negative ninth power, I'm going to bring it down to my denominator and make it a positive ninth power. And then in my parentheses here, I'm going to multiply these two exponents. 9 over 3 and negative is going to be to the third power, but that's still negative. I'm going to bring that all down into the denominator as well. So let's just start rewriting here. I'm going to be bringing my nm squared to the positive third power. I've got a 25 to the ninth power down there as well. See, that takes care of this thing, takes care of all this. Now I have 2nm times 4 squared. So let's go ahead and take our 4 squared, which is 16, multiply it by this 2 here. That gives me 32, and then I've got nm. Alright, let's see where this takes us. I'm going to bring this over and take everything in this set of parentheses to the third power. That 25 to the ninth is going to be a huge number, so I'm going to just keep it written as 25 to the ninth power. I've got 32 and m. I'm going to write my number first here. N to the third, m to the sixth. I can do some canceling of n's here. This becomes n squared. This m becomes just a 1 there. This becomes m to the fifth. So I think if I've done this correctly, this is my final answer. Okay, I think we're good there. If you find a mistake, don't forget, you can always bring it to my attention in class and we can sort out some starbursts. Otherwise, we've got this one last example to go and a couple different ways you can get it. Actually here, what I'm going to do is give you the final answers, a couple different versions on this. See if you can get to this answer on your own. I got one version as 1 over 2 to the 5/6 power times x. We could also write that as 2 to the negative 5/6 x to the negative 1. Some of you might also, just because you might see it this way on a multiple choice, be able to recognize that this is 1 over x times 6th root of 2 to the 5th. All right. See if you can come up with that same answer or show me why that answer is wrong. And we will look at that one on Monday in class. All right, have a good afternoon, everybody, and study hard for that midterm exam coming up.